Hey parents and students, welcome back to this week's video on division algorithms. So what we're going to start with is, what is an algorithm? Because this can be kind of a tricky word. So an algorithm is something that we use where we follow multiple steps to do our calculations to get to an answer. So we've worked with algorithms before with multiplication, but now that we've moved on to division, we have some new ones to learn. So we're going to start with the traditional algorithm. Now the traditional algorithm is what I used to learn in school, what your parents used to learn in school, but we'll get to talking about why we kind of want to use some new algorithms when we're doing division. So the first problem we have is 632 divided by 4. So when you start with the traditional algorithm, you want to think you're starting in the hundreds place. So how many times do I think 4 can go into 6? Well, I know that 4 can go into 6 one time. So we're going to write subtract 4. We're going to take our 1 up here because 4 went into 6 only one time. And we know that 6 minus 4 equals 2. So after this, we still need this 3, or 30 technically, because it's in the tens place. So we'll carry that 3 down, and we have 23. So this time we're doing the same thing. How many times do I think that 4 goes into 23? Let's think. I know that 4 times 5 is 20. And so we're going to do 5 up here and minus 20. And we have our 3 left over. So we have our 2 left down here, and we're going to draw an arrow to bring that 2 down. So we have 32. So now we have to think, how many times does 4 go into 32? So I know that 8 times 4 is 32. So we're going to draw our 8 up here and minus 32. 32 minus 32 is 0. So our answer is 158. So 4 goes into 632 158 times. But sometimes with division, we know that it's not always an complete number. Sometimes we have a remainder. So let's go over here with the traditional algorithm and use the same steps. So we're going to start with the 7, which is in the hundreds place. And I know that 5 goes into 7 one time evenly. So we're going to put our 1 right here, minus 5. 7 minus 5 equals 2. We're going to bring our 2 down. We have 22. So how many times does 5 go into 22? 5 times 5 would be 25, so that's not it. So what about 5 times 4 equals 20? So let's draw our 4 up here, minus 20, and you have 22 minus 20 is 2. We have to bring our 3 down, and we have 23. Okay, so now we have the 23, and we have to think, how many times does 5 go into 23? Once again, 25. 5 times 5 would be too much, so we have 5 times 4, which is 20. So subtract our 20, and we have 3. Now 5 can't go into 3. So we have, first we have to write our 4 up here, since we did 5 times 4 to get 20. And we have 3 left over. So we will have remainder, you just write an R of 3. So our answer is 144 remainder of 3. So 5 goes into 723 144 times, and you'll have 3 left over. So that's how we do our traditional algorithm, where you're kind of just following your steps, but it's hard to take into account our place value that we've been working on, and it's kind of hard to follow. So let's move into the alternative algorithm. Okay, so now we're going to learn an alternative model, or alternative algorithm for division. So what I'm going to teach you today is the area model. So what's so awesome about math math is that there's so many ways to get to the same answer. So this is just going to be one alternative way that we're going to learn today on how to get to the same answer that we got to with the problems we just worked on with the traditional algorithm. So the area model, we're going to start off with the same problem we did earlier. So we're going to do 632 divided by 4. So how we're going to start is we're just going to draw a rectangle. And this rectangle has an area of 632. So that's what we're going to start with. So we're going to just divide this into a chunk. And we're going to divide by 4. So that's going to be right here. And we'll start with our 632 at the top. So this is our first chunk, and we want to think how many times that we know of, that we can think of off the top of our head, can we get 4 to go into 632. So thinking about it, I'm going to say 4 times 100. So we would put the 100 up here, and then I know that 4 times 100 would be 400. So we're going to subtract 400 from our whole area of the 632 that we're starting with. So 632 minus 400, bring the 2 and the 3 down, 6 minus 4 equals 2. So we have 232 remaining out of our whole to spread out through the rest of this rectangle. So we know that we need another piece of the rectangle, and we're going to take this 232 we have left over and move it right up here. So we're going to do the same thing. We're going to think in our heads, what's the best number that we can multiply 4 by to get into 232? Because we're trying to fit 4 into 232 so many times. So the number that I know that works would be 50, because 4 times 50 is 200. So I'm going to write 50 up here, and I know that equals 200. So 232 minus 200, you are left with 32. So now we still have the 32 that we have to deal with. So we have our other piece of the rectangle. We'll take the 32, move it over here. And based on what we know about our multiplication facts, we know that 4 times 8 equals 32. So you subtract your 32, and that equals 0. So what we want to do now is we're adding the numbers at the top from each of our chunks of our whole rectangle, and that gets us 158. So the answer to our problem, 632 divided by 4 equals 158. So now that we solved that using the area model, let's look at how this compares to our traditional model that we just did. So we're doing the same problem, but the way that we're doing it is different. So you're getting the same numbers, but they're just showing up differently. So something that we can notice is that here we got the answer of 158 up here. And up here we have 100 plus 50 plus 8. So our hundreds, our tens, and our ones, which still equals 100. Okay. And then something else that we can notice when looking at the traditional algorithm. If you look at the top, and you just covered this up, and you know that the 1 is in the hundreds place. So you cover this up, it's 4 times 100. Right here, we have 4 times 100. This is 4 times, not 5, but times 50, because it's in the tens place. Right here, we also have 4 times 50. And the same thing goes for the ones place. We have 4 times 8 and 4 times 8. So now you know how to use the traditional and the alternative area model. And so we can see that we got the same answer, we just arrived to the answer differently. So this one takes more drawing the arrows down and realizing that you're not really taking into consideration that this is not 6, it's 600. This is not 3, it's 30. This is in the ones place, so it's just 2. You're just drawing arrows down. You're not really thinking about the place value that we've worked on. With the area model, we're breaking it down into hundreds, tens, and ones, which helps us out with working with our place value and our division. So we're going to later on introduce more alternatives to our division, but let's keep working on our area model and drawing conclusions as to how the traditional and the area models can be the same if you look at them like up here at the top and up here at the top, and you just break down the numbers. So we'll see you in the next video.